Here's a problem where I am to add two integers, and the idea is for you to learn ways to do this without using a calculator. So one way you can add integers, especially if one of the numbers is close to 100, say, what you can do is rewrite the addition problem to an equivalent one where the first number is 100. Then when we're done, we need to evaluate, meaning do the calculation and report the result. One way to think of 97 plus 13 is that we have two separate groups of things, and since we're adding, you can think of it as we're putting those groups together. So suppose you thought of the number 97 as having 7 units, since there's a 7 in the ones place. So here's 7 dots representing 7 units. The 9 in the tens place representing 90, I will use 9 rods to represent that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's 97 things in one group, and I am to add 13 more. So there's a 3 in the ones place. I'll put 3 dots representing those 3 units, and then a 1 in the tens place represented by drawing 1 rod to represent 10 units. So because this is an addition problem, if I were to move things from one group to the other, it would not change the sum, because after all, I am just to add up total what I have. So one way to think of doing the problem is it would be easy to add these numbers in my head if the first number was 100. I could make the number of things in this group 100 rather than 97 if I only added on 3 more units. Where would I get those 3 units from? I could take them from the second group. So I have 97 now. If I move 3 over, having moved 3 over changes the amount in each group. I would no longer have 97 units in this group. I had 97, but since I put 3 more in here, I'd have 98, 99, 100. So this math problem is equivalent to another math problem whose first digit is the number 100, and now this problem is starting to make sense. We are rewriting the addition problem by creating an equivalent problem where the first number is 100. Because the first number is 100, this should be easier to add in my head. Now, one thing you have to notice is that we no longer have 13 units in this group. There were 13, but I moved 3 away. So you think of it as I took 3 of the 13 and I gave them to this group over here. So this group got 3 more, making 97, 100, but this group lost 3. So it no longer has 13. You could count down 12, 11, 10. Or you could just realize that there's only 1 rod left here, meaning there's only 10 units left. So adding 100 plus 10 is rather easy. It is 110. Much easier, say, than adding 97 and 13. What you could try to get good at is if you had the problem 97 plus 13, rather than drawing rods and dots to represent the numbers, you could think of it to make this 97 the number 100, I would have to take 3 away from the 13 and give it to the 97. So if I took 3 away from the 13, I would have 10 left over here. And if I gave those 3 to this group, there wouldn't be 97, there would be 100. Let's do a similar example. Here's another example. So I'm going to start by saying that we have 98 things in this group. That would be 9 rods. And so that I don't have to keep counting them, I'm going to circle them and remind myself that this group represents 9 rods. I have 8 units. 1, 2, 3, 4, 5, 6, 7, 8. And rather than keep counting them, I'm just going to circle them and remind myself that, that the units in this group here have 8 units in them. Now we are to add that to a group of 15, which would be 1 rod and 5 units. Small enough numbers that I don't feel like I have to group them in this way. Now, since we're adding the 2 groups, it doesn't matter if the units and rods are over here in this group or over there, since we're just supposed to add them all together and find the total. So for example, this problem would be easier if the first number wasn't 98, if it were instead the number 100. What would I have to do to get the number 98 to get up to 100? Well, I'd have to move 2 of the units from this group over here. So since I have 98, moving 1 over would make 99, and moving one more over would make 100. So by doing so, I now have 100 units in this group. Here's my 9 rods, meaning 90, and here's my 8 units, so together this is 98, but now I have 99, 100 units in this group, but since I moved the 2 over here, I have 2 less units over in this group. So now I only have 13 units here. So what you can see what happened is, to make the number 98 into 100, I had to move 2 units over. So this group no longer had 15, it only had 13. And this group gained 2 units, the ones that I moved over, so it no longer had 98, it now has 100. So the idea is that it is easier to do the problem 100 plus 13 than it is to do 98 plus 15. 100 plus 13 is simply 113. This problem is a little different in that it is a subtraction problem, so the directions have been changed a little to say that we are to rewrite the subtraction problem by creating an equivalent problem where the first number is 100. Meaning we need to take this subtraction problem and write it as 100 minus some number, and the idea is that the value here is equivalent to the value here. So to explain this, I want to first do a simpler problem. So let me move this off to the side for a second and show you that had the problem been simpler, say the number 10 subtract 6, that you could think of subtraction in the following way. Suppose I had 10 things, and my job is to subtract off 6. One way to subtract off 6 would just be to take all 6 things and simply take them away, and I'd be left with 4, so 10 minus 6 would be 4. However, I want to look at it a different way. Suppose it was to my advantage to subtract 6 in 2 steps. Suppose rather than subtracting all 6 at once, that step 1 was to take my 10, first subtract off 2 of them, they would be gone, and then after I subtracted 2, I decided that since I needed to eventually subtract all 6 of these, that I would need to subtract 4 more as a second step. So subtracting 6 is equivalent to subtracting 2, and then following that, subtracting 4. In either case, you're left with 4 as a final answer. So the idea is, rather than subtracting off all 6 dots at once, you can break the 6 into pieces and subtract off each piece one at a time. So at this point, this may not seem useful, but let's go back to our original problem. Our original problem wasn't 10 minus 6, it was 102 minus 6. And we are to write that subtraction problem as 100 minus a number. I'll put a question mark here, and our job is to find that question mark. So the idea is, if I want the 102 to become a 100, I would have to subtract 2 off. But I'm not supposed to be subtracting 2, I'm supposed to be subtracting 6. But much like I showed a few seconds ago, if you were to subtract off 6 things, what you could do is do it in 2 steps. Rather than taking 102 and subtracting off all 6 units at once, I could break it up into subtracting 2 things, and then after that subtract 4. Meaning I could think of the number 102 minus 6 as 102. Instead of subtracting all 6 at once, I could do it in 2 steps. The first step would be to subtract 2. The second step would be to subtract 4. So if you see what I have here, taking 102 and subtracting the first 2 of the 6 dots gives me 100. But since I've already subtracted 2, I only need to subtract 4 more, that would be my question mark, to make it so it's the equivalent of subtracting 6. Meaning I've subtracted 2, if I subtract 4 more, I will have subtracted all 6 dots. So 102 minus 6 can be thought of as 100 minus 4. Now that I have that, I need to evaluate or calculate the result. My calculated result would be if you had 100 things and you took away 4, this would give you 96. I'd like to do one more problem that's a subtraction problem, for which we need to take the subtraction problem and write an equivalent problem where the first number is the number 100. So what I'm going to have to do is to make the number 101 into the number 100, I will have to subtract 1 to get from this number to that number. So rather than subtracting off 8 all at once, so to speak, I want to subtract 1 to turn the number 101 into the number 100, and then subtract the remaining. So think of the number 8 as you have 8 units. I'm going to represent those units just with dots. So I have my 8 dots. One way to think of subtracting 8 is to subtract off all 8 things at once, but I want to break it up into pieces. Because I need to only subtract 1 unit to get from 101 to 100, I'm going to break it up so that we're only subtracting off one of the units first. So I'm going to write the equation as 101, and I'm going to break the subtraction of 8 into 2 pieces. First, I'm going to subtract 1, so that 101 minus 1 gives me the 100. But I ultimately have to subtract off 8 things. So far, I've only subtracted off 1. So I still have 1, 2, 3, 4, 5, 6, 7, meaning I had 8 things, took 1 away already, so I have 7 more to subtract. So subtracting 8 can be thought of as subtracting 1 and then subtracting 7. So the idea now is that when you take 101 and you subtract off 1 thing, you'd be left with 100. But since you have to subtract off 8 things and you've only subtracted 1 so far, you'll have 7 more things to subtract. The idea is that 101 minus 8 is a harder problem than 100 minus 7. So when you get good at doing 100 minus 7, you've made a more difficult problem into an easier problem. 100 take away 7 is equal to 93. And I must actually calculate the result because the directions were to evaluate. Evaluate means find the value of the expression. Finding the value of the expression means to actually calculate the result.